A ball is thrown vertically upwards from a building so that position y meters at time t is shown by the graph. So here we have the time t, and here we have the position. It says A, what is the initial position of the ball? What is the displacement of the ball relative to the starting position at t is equal to 8? When does the ball have the same displacement? What is the time of and the maximum height the ball reaches? What is the displacement relative to its starting position at t is equal to 3.2? And what is the total distance travelled by the ball during the motion? Right, to do this, I'm going to use a Geogebra Applet. So the first part is, what is the initial position of the ball? So if we jump to this Geogebra Applet here, so you're just going to have a look at the motion of the ball to begin with. Now the link to this Geogebra Applet is in the notes of the video on YouTube. So if we press the start button here, and we'll just click to reveal the ball. So we've got a ball here. This is the ball, so it's thrown upwards, vertically upwards. So it goes up, you can see that it goes up and reaches a certain height and then goes back down. So if we just reset that, we'll do that one more time. So this is the path of the graph, its position relative to the time t here. So eventually, if you throw a ball upwards, it will come back down to Earth. Okay, so let's have a look. So the initial position of the ball is given by this point here, about 6 meters will be the initial position. This is where the start, so the height of the building is actually 6 meters. So on your graph, you should annotate that, write down 6 meters, and that the initial position is there. Therefore, the initial position is 6 meters. Okay, so then it says the displacement. Now, interesting use of the word displacement, because remember, displacement is a vector quantity, so it has a distance in a certain direction of the ball relative to the starting position. So if we jump back to this, and we're on click that one, click this one. So on your graph, you need to find 0.8, draw a line up to the graph, and then across, and then you read off here. Now you need to make note of the scale, so each one of these little things is 0.4, so that's going to be 14.8 meters. So on your graph, you should do that. Make sure that you do annotate graphs in A level, or IB for that matter. So obviously then, now we want to find the displacement. Now the displacement isn't 14.8, because it says the displacement relative to the starting position, so it's going to be 14.8 minus 6. So this is going to be the displacement. This distance here is the displacement. It's positive because it's going upwards, so we have to take away 6 and we get 8.8. Okay, again making sure we've annotated our graph. Okay, next part, the time at which the same displacement position of the ball. Okay, so if we go back to our Geogebra Applet, okay, and if I click the second one, part C here, okay, we can see that it reaches this height at a second time here. So on the way up it reaches 14.8, and on the way down it reaches 14.8, and that will happen at 2.2 seconds. So this particular point here, okay, so the time will be equal to 2.2 seconds. Part D, the time of the maximum height of the ball, time of and the maximum height the ball reaches. So going to our Geogebra Applet, just get rid of these to begin with. So the maximum height will be the maximum point on the graph, which happens to be here. So again, to annotate, so reading off the graph at 17.2, that's 16.4, 16.8, 17.2. Next one will be 17.6. You need to read off, make sure you get the right scale. So 17.2, and that will happen at 1.5 seconds. So again, annotate your graph. Okay, so the maximum height will be that. Okay, so the ball reaches a maximum height of 17.2 at t is equal to 1.5 seconds. Now, it didn't say the maximum displacement, but the maximum displacement relative to the starting position, which is there, is going to be that. That's the maximum displacement. And to get that, you'd have to do 17.2 minus 6, which gives me 11.2. Now, you're not asked to do that, but that's how you would do it if you had to find the maximum displacement. Right, the displacement relative to the starting position at t is equal to 3.2. So if we now go back to our Geogebra Applet, unclick this one, and you can click this one. So we find 3.2, read up our graph, and we find we get 2.8. Make sure we read the scale properly. 2.8. But that's not the, that just gives me the position at 3.2. I want the displacement. So the displacement is now under the starting position. So I now have to do 2.8 minus 6, which gives me minus 3.2 meters. It's negative because it's under the starting position, and that's considered to be the 0 for displacement. Okay. Right, the final bit is the total distance travelled by the ball. So if we go back to the applet, okay, we'll just uncheck that and just do the animation again, just looking at this bit only. The ball goes up, okay, and then goes back down all the way. All right, so display a distance is the total distance travelled. The displacement is going to be minus 6. The total displacement is minus 6. But we want the total distance. Okay, so a little diagram here. So it starts here. Sorry, to get that on the applet, you need to click over here on F. Okay, so it goes up 11.2 and then back down 17.2. So up 11.2 and back down 17.2. So it gives me 11.2 upwards, and because distance is a scalar quantity, we don't have to worry about direction. 17.2 downwards, and that gives me an answer of 28.4 meters. However, note the final displacement is equal to minus 6, okay, because it is minus 6 from its displacement. So just going back to our Geogebra Applet, okay, so your diagram will look something like that when you have finished with all those annotations on. So good idea to make sure you have a good ruler, put lots of arrows on, maybe use a bit of colour, and that you've annotated your graph properly. Now, the link to this Geogebra Applet I will put in the notes of this video. Okay, so this has been a video to explain the motion of a ball thrown upwards, looking at two quantities, displacement and distance. Remember, displacement is a vector quantity and distance is a scalar quantity. I hope you've understood, and I thank you very much for watching.